Have you ever wondered what you would look like on an atomic level? Or how much space in a container you would take if you accidentally liquefied yourself? Maybe you've wondered about the possibility of changing the atoms of an entire planet to form one giant pizza in the shape of an L on your forehead, grant you the knowledge about the wonders of matter. Heard of? We'll start with the first four most common states of matter. These are the ones that allow you to do everything: eat, sleep, watch this video, complain about your life and do nothing to change it. And the list goes. Depression. Your current state at the moment is the solid state. In a solid, constituent particles are closely packed together. They cannot move freely, but only vibrate. Something else that's long and vibrates is an electric toothbrush. A solid has a stable, definite shape, and a definite volume. Solids can only change their shape by an outside force, as when broken, cut or smashed by something heavy like the debt of the United States. Now on to the liquid state. A liquid is a nearly incompressible fluid that conforms to the shape of its container but retains a nearly constant volume independent of pressure. These liquids can be as colorless as when a solid is heated above its melting point. Say iron. It becomes a liquid at 1538 degrees Celsius, and for the Americans, 2800 degrees Fahrenheit. Molecules have enough energy to move relative to each other and the structure is thus mobile. Is determined by its container. The volume is usually greater than that of the corresponding solid. Water. The gaseous state. The state that most kids like to make jokes about. A gas is a compressible fluid. Not only will the gas conform to the shape of its container but it will also expand to fill the container. The molecules have enough kinetic energy so that the effect of intermolecular forces is small or zero for an ideal gas. And the typical distance between neighboring molecules is much greater than the molecular size. A gas has no definite shape or volume just like a liquid, but occupies the entire container in which it is confined. We forgot the one that every nerdy kid likes to remind the teachers about. What are we going to talk about next? A. Gamer girl bath water. B. A superfluid. C. Plasma. Or D. Liquid debt. Plasma. Now, like a gas, plasma does not have definite shape or volume. Plasmas are electrically conductive, produce magnetic fields and electric currents, and respond strongly to electromagnetic forces. Positively charged nuclei swim in a sea of freely moving dissociated electrons, similar to the way such charges exist in conductive metals. Ways. Either from a huge voltage difference between 2 points, by exposing it to extremely high temperatures, or by taking the gas and putting it in a bottle and then let it get struck by lightning in Minecraft. Heating matter to high temperatures causes electrons to leave the atoms, called partially ionized plasma. At very high temperatures, such as those present in stars, the Karens making a ruckus in America, this forms the so-called fully ionized plasma. Phase transitions. That's how we describe going from one state to another. Not by car, but by sublimation, from solid to gas. Deposition. Going from a gas to a solid. Ionization, in which atoms, well, get ionized. Deionization. Freezing. Melting. Vaporization and condensation. There are a lot of other states of matter as well. For example, low-temperature states. These include superfluids, a liquid close to absolute zero. Because it has no viscosity, it can climb the walls of the container like here. The Bose-Einstein condensates. Discovered by, you won't believe it, Satyendranath Bose. A Bose-Einstein condensate is colder than a solid. It may occur when atoms have very similar or the same quantum levels, at temperatures very close to absolute zero. It also results in some nice phenomena. Fermionic condensates. Pretty similar to the Bose-Einstein condensate but composed of fermions, particles that generally have half-odd integer spins. Rydberg molecules. One of the metastable states of strongly non-ideal plasma is Rydberg matter, which forms upon condensation of excited atoms. These atoms can also turn into ions and electrons if they reach a certain temperature. The quantum Hall state. A quantum Hall state gives rise to quantized Hall voltage measured in the direction perpendicular to the current flow. Photonic matter. Photons interacting with a gas develop apparent mass and can interact with each other, even forming photonic molecules. Droppleton. A quantum fog of electrons and holes that flow around each other and even ripple like a liquid, rather than existing as discrete pairs. We also have high-energy states and very high-energy states. In these we have degenerate matter, quark matter and color glass condensates. All of the previous are high-energy states, but we also have very high-energy states. An unknown state has created the baryon asymmetry in the universe, but little is known about it. In string theory, a Hagedorn temperature is predicted for superstrings at about 1030 Kelvin, where superstrings are copiously produced. At the Planck temperature of 1032 Kelvin, gravity becomes a significant force between individual particles. No current theory can describe these states and they cannot be produced through any foreseeable experiment. However, these states are important in cosmology because the universe may have passed through these states in the Big Bang.